Splicing a neutral conductor within a 150 amp electrical panel using a split bolt is a violation of the National Electrical Code. The NEC mandates that all electrical splices must be performed within an approved enclosure, such as a junction box, and utilize splicing devices that are specifically listed and labeled for the intended application. Split bolts, while suitable for certain grounding and bonding applications under specific conditions and when properly listed, are generally not approved for splicing current-carrying conductors, especially neutrals, inside an electrical panel. The primary reason for these stringent requirements is electrical safety. Improperly made or unapproved splices can pose a significant fire hazard. A loose connection, for example, can create resistance in the circuit. This resistance generates heat, and over time, this heat can degrade the insulation of the wire, leading to arcing. Arcing is a dangerous phenomenon where electricity jumps across a gap in the connection, creating a high-temperature plasma that can easily ignite surrounding materials. The National Electrical Code exists to minimize these risks and ensure the safe operation of electrical systems. The specific NEC articles that address splicing requirements include Article 110.3, which covers examination, identification, installation, and use of equipment, Article 300.15, which details boxes or fittings where conductors are spliced or terminated, and Article 314, which pertains to outlet, device, pull and junction boxes, conduit bodies, fittings, and handle enclosures. These sections emphasize the necessity of using listed and labeled equipment and installing them according to the manufacturer's instructions. When splicing conductors, appropriate methods and materials must be selected. These include wire connectors listed for the specific conductor types and sizes being joined. The connectors must be properly tightened to ensure a secure and reliable electrical connection. Furthermore, the enclosure in which the splice is made must provide adequate protection from physical damage, moisture, and other environmental factors that could compromise the integrity of the splice. In the scenario described, splicing the neutral conductor inside the electrical panel with a split bolt introduces several potential problems. Firstly, the panel itself is not designed or listed as a junction box for splicing conductors. Secondly, split bolts are not typically listed for splicing neutral conductors within panels. The panel's environment, which can be subject to temperature fluctuations and potential condensation, further exacerbates the risk of corrosion and loosening of the connection. The presence of a steady reading on the lugs, while seemingly indicating a good connection, does not guarantee long-term reliability or code compliance. A seemingly tight connection can still harbor microscopic gaps that promote corrosion and eventual failure. Furthermore, the no-ox compound, while helpful in preventing oxidation, does not negate the fundamental requirement of using approved splicing methods and enclosures. To rectify this situation, the improper splice must be removed and replaced with an approved method. Firstly, to energize the circuit by switching off the main breaker to ensure personal safety. Secondly, carefully remove the split bolt and clean the existing neutral conductors. Thirdly, install a junction box adjacent to the panel, ensuring it is securely mounted and properly grounded. Fourthly, use wire connectors that are specifically listed for splicing neutral conductors of the appropriate size. Fifthly, make sure the conductors are properly installed inside of the junction box. The junction box needs to be appropriately sized based on NEC Table 314.16A and 314.16B to ensure there is adequate space. When calculating box fill, each conductor that passes through the box, each conductor terminating in the box, and any devices such as splices or terminals all contribute to the overall fill. The conductors are counted based on their size. For example, a number 14 American wire gauge conductor counts as 2 cubic inches, a number 12 American wire gauge counts as 2.25 cubic inches, a number 10 American wire gauge conductor counts as 2.5 cubic inches, and a number 6 American wire gauge counts as 5 cubic inches. The junction box should be accessible. The proper supports for the junction box are defined in NEC section 314.23. Non-metallic boxes shall be supported from a structural member of the building or from grade when supported from grade. The junction box needs to have a cover that is suitable for the environment. If it is damp or wet, a wet location cover needs to be selected. In addition, ensure that the neutral conductor is properly identified with white or grey colored insulation or markings. This is crucial for maintaining proper polarity and preventing accidental connections that could lead to short circuits or equipment damage. The neutral conductor carries unbalanced current from the circuit back to the source. It is typically grounded at the service entrance, creating a reference point for the electrical system. This grounding helps to stabilize voltage and provides a path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to trip and energize the circuit in the event of a ground fault. Proper neutral connections are essential for the safe and reliable operation of electrical equipment. A loose or improperly made neutral connection can cause voltage fluctuations, equipment malfunction, and even electrical fires. Therefore, it is imperative to adhere to the National Electrical Code requirements for splicing neutral conductors and to use only approved methods and materials. In summary, splicing a neutral conductor inside an electrical panel with a split bolt is a code violation that poses a significant safety hazard. To ensure the safety and compliance of the electrical system, the improper splice must be replaced with an approved method in a properly installed junction box. This includes energizing the circuit, removing the split bolt, cleaning the conductors, installing a junction box, using laser wire connectors, ensuring proper grounding and identification of the neutral conductor, and verifying the integrity of the connections. Adhering to these guidelines will help to prevent electrical fires, protect equipment, and ensure the safe operation of the electrical system.